Hello guys, my name is Alfred Sarmiento from BSIT 1205. So from the last vlog, I have discussed the summary of chapter 2. For this vlog, I'm going to discuss the summarized form of chapter 3. So chapter 3, uh, the topic for chapter 3 is the network protocols and communication. So for our communication fundamentals, right, if you're also humans, we also have the human communication. So in our human communication, we also need the process for the human to have a communication is the message source or the message that's sent by the sender, transmitter or the signal. The third one is the transmission medium, receiver, the one who's receiving the message, and lastly the message destination. This means that the message that the sender send was received by the receiver. So in message encoding, one of the first steps to sending a message is encoding, because encoding is a process of converting information into another acceptable form. So for the other encoding, which is the decoding reverses the this process that the encoding do. So for the message encoding, we have the message source, of course, that's the message. Encoder, signal, which means also the sender, transmitter, transmission medium, or the channel, the receiver, the decoder, and the message destination, which the sender sends the messages. Now, for the message size, that all of us know that if we're going to text to another person. Example, a long sweet message. Sometimes long sweet messages don't send because of too much text that are written in the text. So for us to deliver those texts, we need to cut each text that you have sent for them to send, because too much text can be sent to another sender because it has too much information written on the context. So in our message timing, we have three, which are the access method, flow control, and the response timeout. So for in our access methods determines when someone is able to send messages. So if, so the next one will be the flow control. Timing also affects how much information can be sent and the speed that can be delivered. While in the response timeout, if a person asks a question and does not hear a response within an acceptable amount of time. So for the access method, this process tells if the sender was able to send the message to the receiver. So for the flow control, uh, this is the information that the time of information can the sender send to the receiver. While for the response timeout, if the receiver was not able to receive the information that the sender sent to him or her. In message delivery options, we have three delivery options. These are the unicast, multicast, and broadcast. For the unicast, the source was able to give to another user, but only one user, or only one receiver. And let's tell that the source, example, the sender and the receiver. And the sender send to a one receiver. That means that is a unicast. So in multicast, source and the two receiver. So the source gives the information to the two receiver, which that's what you call the multicast. So for the broadcast, the source and a lot of receiver So that's what you call the broadcast delivery. So in our protocol interaction, so for the HTTP, which means the Hypertext Transfer Protocol, that's for the application. So for Transmission Control Protocol, or as what you call TCP, these are for the transport. For the Internet, we have the Internet Protocol, also called as the IP. Ethernet, which are located in the network access. HTTP is an application protocol that governs the way a web server and a web client interact. TCP is a transport protocol that manages individual conversation. IP is responsible for taking the formatted segments for TCP, encapsulating them into packets, assigning them the appropriate address, and delivering them to the destination host. So for the Ethernet, is a network access protocol that describes two primary functions: communication over a data and link, physical transmission of the data on the network media. So for our Internet standards, where we have the Internet Society, Internet Architecture Board, Internet Engineering Task Force. So for our Internet Society, responsible for promoting the open development and evolution of Internet use throughout the world. Internet Architecture Board, or the IAB, responsible for the overall management and development of Internet standards. So for our Internet Engineering Task Force, so the AETF, develops, updates, and maintains the Internet and TCP/IP technologies. This includes the process of documents for developing new protocols and updating existing protocols, as known as the Request for Comments. Internet Research Task Force, or the IRTF, focus on long-term research related to Internet and TCP or IP protocols such as Anti-Spam Research Group, ASRG, Crypto Forum Research Group, or the CFRG, and the Peer-to-Peer Research Group. This also includes Internet Corporation for Assigned Names and Numbers, or the ICANN, based in the United States, coordinates IP address allocation, the management of domain names, and assignment of other information using TCP and IP protocols. Internet Assigned Numbers Authority, or as we call the IANA, responsible for overseeing and managing IP address allocation, domain and name management, and protocol identifiers for ICANN. So for our OSI reference model, we have the physical, data link, network, transport, session, presentation, and application. So for our physical layer protocols describe the mechanical, electrical, functional, and procedural means to activate, maintain, and deactivate physical connection for bit transmission to and from a network device. So the next is the data link. So the data link layer protocols describe the methods for exchanging data frames between devices or over a common media. The next is the network. The network layer provides the service to exchange the individual pieces of data over the network between identified and end devices. So the next is the transport. So transport layer defines the services to segment, transfer, and reassemble data for individual communication between the end devices. So for the session layer provides the services to the presentation layer that organize each dialogue and to manage data exchange. So the next one is the presentation. The presentation layer provides for common representation of data transferred between application and layer services. So the next is the application. The application layer contains protocols used for process-to-process communication. So that's the iOS reference model. So for our segmentation, or the communicating the messages, segmentation breaks into communication to pieces, while multiplexing interleaving the pieces as they reverse. So now let's proceed to encapsulation. When sending messages on a network, the encapsulation process works from top to bottom. At each layer, the upper layer information is considered data within the encapsulated protocol. For example, the TCP segment is considered data within the IP packets. So next, let's proceed to the encapsulation. This process reverses at the receiving host and is known the encapsulation. The encapsulation is the process used by receiving device to remove one or more protocol headers. The data is encapsulated as move up the stack towards the end user application. So for our network address, network layer source and destination addresses are responsible for delivering the IP packets from the original source to the final destination. So for the data link layer, source destination addresses responsible for delivering the data link from one network interface card to another on the same network. The IP packet contains two IP addresses. These two IP addresses are the source IP address and the destination IP address. So what is source IP address? The source IP address is the IP address of the sending device or the original device source of the packet. So the destination IP address is the IP address of the receiving device, the final destination of the packet. So the same as goes as the sender and the receiver. Those the sender is the source IP address and the receiver was the destination IP address. And that's all for the chapter 3. Now let's move on for the chapter 4. Bye. Next time again.